Welcome to the second part of my video. We're gonna do Wireshark packet operations. And now we're in a filter packets section. Okay. So now we got capture filters and display filters. Capture filters, this type of filter is used to save only a specific part of the traffic. It is set before capturing traffic and not changeable during the capture. Display filters. This type of filter is used to investigate packets by reducing the number of visible packets and is changeable during the capture. We're gonna see it in the practical section. And first, before I read that, I'm gonna turn on the machine. Okay, let's turn it on. And let's continue. Capture filter syntax. These filters use byte offset hex values and mask with Boolean operators. It's not easy to understand and predict the filter's purpose at first glance. The base syntax is explained below. So let's do it. Display filter syntax. Capture filters. We got on this picture. But anyway, this is not important now. Sample filter to capture port 80 traffic TCP port equals 80 and it returns as only the packets that are sent to port 80. It's in Wireshark, it's in the analyze section, display filters, and here we got here. Okay, comparison operators. This is equal, for example, IP source equals and this IP, and we got equal, not equal, greater than, less than, and so on. We're gonna use it also in a practical example in the machine. Logical expressions. Wireshark supports Boolean syntax. We can create display filters by using logical operators as well, like and, logical and, like here, or, logical or, by those two lines. Okay, now just like in the coding, like in Python or other languages. Packets filter toolbar. Here is important that when it's green it's valid filter, when it's red it's invalid, like example in here. And we got a filter toolbar features as shown below. So features of this toolbar, like we can pick one of those and just use it. Okay, I don't need to make answer question here. Let's go to another protocol filters. As mentioned in the previous task, Wireshark supports 3000 protocols and allows packet level investigation by filtering the protocol fields. This task shows us the creation and usage of filters against different protocol fields. IP filters. It helps analysts filter the traffic according to the IP level information from the packets. Network layer of the OZ model. This is one of the most commonly used filters in Wireshark. These filters filter network level information like IP address, version, time to live, time of service, flags, and checksum values. The common filters are IP address equals, and so on. IP destination, IP source. TCP UDP filters. Hub analysts filter the traffic according to protocol level information from the packets transport in the transport layer of OZ module. These filters filter transport protocol level information like source and destination port sequence number, acknowledgement number, window size, timestamps, flags, length, and protocol errors. We got TCP port equals 80 and shows all the 80 ports packets. TCP source port 1234. So it shows us all TCP connections with port 1234. TCP destination port equals 80. So all the packets sent to port 80. And this one actually was TCP source port, so it's a packet originating from 1234 port. Let's go further. Application level protocol filters, HTTP and DNS. So those protocols are the most used. The HTTP show all HTTP packets, DNS show all DNS packets. Simple as that. HTTP response code equals 200, so it's responsive, or 404, it's not responsive, but we're gonna be more interested in 200s. HTTP record request method equals get, so all the request methods that are equal get in the HTTP protocol. HTTP request method equals post, so the same. And here we got with DNS, show all DNS packets, DNS flags response equals 0, show all DNS requests. DNS flags response equals 1, show all DNS responses. DNS QRY type equals 1, show all DNS A records. Here we got some image, and it shows source, destination, protocol, HTTP, and here some information in binaries. But anyway, let's go deeper. As mentioned earlier, Wireshark has built-in option display filter expression that stores all supported protocol structures to help analysts create display filters. When an analyst can't recall the required filter for a specific protocol or is unsure about the assignable values for a filter, the display filter expressions menu provides an easy-to-use display filter build guide. It's available under the Analyze Display Filter Expression menu. So Analyze Display Expression, and it shows all the filters. That's very useful when you're searching for something and it's all ready to copy or ready to use. Filters. It's impossible to memorize all details of the display filters for each protocol. Exactly. So each protocol can have different fields and can accept various types of values. The display filter expression menu shows all protocol fields, accepted value types, and predefined values. So yeah, you can actually remember all of those, and you can actually use not one but two or more filters. The Wireshark Basic introduced the coloring rules. Now you know how to create display filters and filter the event of interest. You can use the View Coloring Rules menu to assign colors to highlight your display filter results. Okay, so let's turn on the machine and we're gonna see what's going on there. we need to use this one, the exercise PAC PNG in Wireshark. It's turning on and let's analyze it. What is the number of IP packets? Okay, I will turn it in a new window so I would see more. So let's open all packets. So we got a lot of it. So how to check all of them? On the packets, yes. We always have displayed here the number of packets. It's 81,530. 81,530. No. But they want IP packets. Some of them could not be IP. So we need to check for all the IP. So for example, in this filter, we can just put IP. Or show all IP packets. IP show all IP packets. So it's 81,420. It's 99%. All packets are 81,530. So another 100, there is something, I don't know, not IP packets. So 420 packets that are IP packets. What is the number of packets with a TTL value less than 10? So TTL is time to live. What is the number of packets with a TTL value less than 10? So now I need to find the filter. With TTL, IP filters, destination, source port. Let's maybe TTL. No. One, I need to find it in Analyze, Display Filters, Expression, search TTL. Nothing shows here. Field name, why it's not here? Because it's here, it's time in this section. Under 10 seconds. You can actually check by this. like it's 39. Let's see, 39. No. Not IP. Time less. Let's check time. This is more, this is less, 10 seconds. And what's going on now? I hope I didn't break the system. Nothing shows. Time 10, no. Time to live. Time to live, no. Let's ask the Google TTL filters. Under 10 seconds. IPTTL. IT, IP, TTL, ten seconds. No. IPTTL under, so it's on the other way around. 10 seconds. Displayed 66. Yeah, 66. Because I put the other way around. Not like this, but like that. Okay. What is the number of packets which uses TCP port 444? And we also had it here somewhere. HTTP, that must be TCP port. It's here, TCP dot port equals 444. And we got 632, it's right here. 632. What is the number of HTTP GET requests sent to port 80? What is the number of HTTP GET requests? So like here. So we need to use this HTTP request method equals Get, but they want us to also provide requests sent to port 80, so it should be end port 80, IP destination, IP source, IP address, IP port. I need IP port, IP port, so destination port or source port. There's a UDP source port, UDP destination port, TCP port 80, so it's 80, yeah, 80, so it's TCP port, so I need to include this one, and TCP destination port equals 80, and let's check if they want us a destination or source port. Send to, so it's okay. We got displayed 527. 527. Yeah, it's correct. What is the number of type A DNS queries? What is the type A DNS? Let's ask, what is the type A DNS? I'm not sure what is it. This is the type A record, often just called an A record, maps domain name or to an IP addresses. So just DNS. DNS replies with an A record containing an IP address. Okay, so they just checked which has the IP address of. Don't forget what? To filter out the LLMNR queries. Okay, so let's make DNS and show all HTTP requests, show all response. So they want us to give the number of type A DNS queries. Application level protocol. Okay, let's check first DNS and what it shows us. It shows us all DNS. Source, destination, length, and so forth. And we got responses here, response, echo, message, response. Okay, so we got all those responses. that are requested. Don't forget to filter out the LMNR queries. What are LMNR queries? I'm not sure what is LMNR queries. Are network requests used to resolve device names on local network when normal DNS does not answer? How to filter out? Filter out. If you want to filter out traffic in Wireshark, use this LMNR. Okay. So we need to. They want us to. What is the number of type A DNS queries? So DNS requests. They want us to filter DNS requests, which are DNS show all HTTP requests. Show all packets with HTTP response code 200. Or maybe let's try this DNS and this symbol and LMNR. DNS, I mean this query type, I mean in this one, DNS query type HTTP post requests equals 1 and gives me 106, but it's not that one, so I only want, so it gives me only requests, I mean responses, because it's one is a response. And when I make query types plus, okay, the machine is getting weird, and we put like, we add another DNS QRI that type equals 0, and we're gonna get what? Nothing. Wait. We're gonna get nothing. And DNS flag response equals 1. It's flags. Now, okay, I made a mistake and DNS query type and equals also 1, and it gives us 51. Let's check if that's true. That is true. Damn, that was a difficult one. Okay,